So today I'd like to just look at some features of the supersymmetry inversion model that I'm developing. And it starts with this He-BEC isotropic universe, the diameter of which is c². And the model provides a way of looking at the inversion of c², 1 over c², as the atomic, kind of like a singularity, but it really, I look at it more as like an event horizon between the atomic landscape and the orbital layers. So there's a boundary of 1 over c², or at 1.1126 e to the negative 17 of a meter in every atom. And that really acts as the inverted lens from the initial isotopic state that the universe was in 13.8 billion years ago. So in that way, we kind of start with, well, if we multiply c² with 1 over c², we get 1. And that really is a basis for providing a balance of opposites. So not only is there this kind of external physical, but there's an internal atomic singularity. So it's like, well, I'm creating a framework for every atom. And the framework of the atom has to have some boundaries to it. And the boundaries are being created by understanding what the original universe looked like in terms of this helium Bose-Einstein condensate and its parameters of electron, positron pairing, the 16 particles per atom of helium, and how they're actually formed through this alpha particle dark energy expansionary phase of the universe and the inward trajectory of 4 particles. So in a way, my model is really looking at the balance of opposites. You could say it's an inverse square law model where the universe and the atom have this inverted relationship from the beginning, and it provides a way of I guess restricting the number of options. So I really look to identify parameters to begin with, and then how those parameters impact on how I see atomic structure. That's quite different from the kind of traditional model that we've been using in terms of protons, neutrons, and electrons in an atom. As I've kind of outlined and presented, I have a kind of a single atom quantum location that I'm really dealing with, and that's kind of inside the aromatic ring of neurotransmitters. So I'm kind of trying to build a single atom model and using the universe cosmological kind of framework to give a mirrored symmetry. What I say by mirrored symmetry, I mean an inversion, 1 over, I guess if you go look at the mirror in the bathroom or wherever your mirror is, maybe in your bedroom, and you look in it and you close one eye and you see that, well, that's my left eye that I'm closing, and when you look, it looks like the eye that's closed is the right eye. So there's this kind of inverted 180-degree rotation, the chirality associated with mirrored symmetry. So in this way, I'm trying to create a mirrored symmetry state in the atomic landscape, and I'm trying to build an atomic relativity as an inverse of the universe's beginning from this He-BEC isotropic singularity. So this is just one parameter that I'm using to do that. The 1 over c squared and c squared, and the relationship between the two. Thank you.